Solving systems of equations by substitution, 6 through 80. So we have to remember what substitution is. Substitution is an algebraic model that can be used to find the exact solution of a system of equations. It involves replacing one of the variables in one equation with an equivalent algebraic expression from another. Okay, so some of you are like, oh, I don't know what that means. That's okay. When I told you that we had this equation, and I tell you that the m value is 3 and the b value is, I don't know, -5. That was a horrible negative. -5. Substitution means that I'm going to replace my m with 3, replace my b with -5. That's substitution. So I'm taking what something equals and I'm plugging it in for something else. That's all substitution is. So what we're going to do is I'm going to have you look at these two equations right here. This equation and this equation. Okay? Y equals 4x minus 7 and y equals 2x plus 5. They both equal y. Okay? So what's going to happen is we're going to take, I'm going to do it right here. We're going to take what y equals, this right here, we're going to bring it straight down, but we're going to take this y and replace it with what we said y equals up here. We're going to replace it. So all we've done is take this and put it right there. We took out the y and just put in 4x minus 7. Now, some of you are, why are we doing that? Well, do you notice now that you only have one variable in the equation? We only have one variable, so we can solve for that variable and find out what x equals. So what they've done is they subtracted 2x from both sides. When they did that, this part went away, and I'm left with a 5 on the right-hand side. 4x minus 2x gets 2x. Then, to get 2x by itself, we're going to add 7 to both sides, divide by 2, and get 6. Okay? But that's only x. We need y also. So what we're going to do is we're going to take this 6 and we're going to plug it in to 4x minus 7. We're going to replace the x with 6 because we just found that. That would get 24 minus 7, which would be 17. Okay, so now we have the point 617 as our answer. And we have to make sure that it's correct. So we're going to take that x value and that y value. We're going to plug it into the original equations and see if it works. And if you look here, it does work. So this right here is the one point where they run into each other. Okay, so here we have this one. They both equal y. So I'm going to replace this y right here with 2x. So I'm going to replace y with 2x. I'm going to solve it. I'm going to subtract x from both sides, and I'm going to get x equals -3. Well, now we have the x value. I need to find the y value. So you can plug it into either one of the equations. The book decided they wanted to plug it into y equals x minus 3. So I'm going to plug it in, and I would get -6. So that's the point -3, comma, -6. So I'm going to plug it back in and make sure it works for both of them. So if I look up at these equations and I was to plug in -3, -6, if I plug that in here, I would get -6. Does that equal -3 minus 3? It does. That one works. I plug it into the other one, maybe. y is negative 6. 2 times negative 3. That is negative 6 equals negative 6, so it does work. So this is the answer. That point is the answer. So I'm going to come down here. I'm going to take what y equals, and I'm going to plug it in for that y right there. So I have 3x equals negative 6 plus x. Subtract x to the other side. I get 2x equals negative 6. I divide by 2 on both sides and get x equals negative 3. I'm going to pick a different color. I'm going to take the equation y equals 3x, and I'm going to replace the x with negative 3. And I get y equals negative 9. So negative 3, negative 9. Now, do I want to make sure that it's correct? And you could just do this in your head if you wanted. Y equals negative 6 plus x. I replace the y. I replace the x. Does that one work? It does, so that's good for that one. I have to plug it into the other equation and see if it works. Negative 9, does that equal 3 times negative 3? That does work. So that is the answer. Okay. Now, not always are we going to have y equals and y equals. Sometimes we'll have something else. So sometimes one or both of the equations in a system may not be written in slope-intercept form. When solving systems by substitution, one of the equations may need to be solved for either x or y. This is important in order to be able to eliminate variables. Okay, so I have the equation 2x plus y equals negative 10. To solve for x, is solve for x and solve for y below. So all it's saying is if I was to solve for y, I would subtract 2x from both sides, and this is what I would get. If I was to solve for x instead of solving for y, I would have subtracted y from both sides. I would have gotten 2x equals negative y minus 10 divided by 2 on everything. And this is what I would have gotten. So it doesn't matter which variable you solve for, you just need to solve for one of them. Sometimes one of them is easier to solve for. If you notice on this one, y had the coefficient of 1, so that one was the easier one to solve for. Okay, on this one, if you notice, this one right here already has y equals. It's already in slope-intercept form. So we're going to take what y equals right here, and we're going to plug it in for this y. So all we're going to do is take away the y and replace it with what it equals. So I'm going to replace it with 3x plus 8. This y went away. It went bye-bye. And it was replaced with 3x plus 8. So now I need to multiply through, and that would get me 12x. Multiply through, that would get me 32. I combine like terms right here, and I get 20x. Subtract 32 from both sides, I get negative 20. I divide by 20 on both sides, and I get negative 1. Okay? So I have my x value. Now I can plug it into either one of the equations, but the easier one to plug it in for is the one that has the variable solved for it already. So I would plug it into the first equation. So I'm going to replace this x right here with the negative 1. That would get me negative 3 plus 8, which is 5. So our answer is negative 1, 5. Okay, so here we are here. Okay, I have what y equals. Right here, I'm going to replace that y with what it equals. So 2x plus 5, taking away the y and replacing it with 6x minus 4 equals 44. So the only thing that changed was this part right here. It's the only part that changed. So I have to multiply through. So I have 2x plus 30x minus 20 is equal to 44. Combine like terms and I get 32x minus 20 equals 44. I add 20 to both sides. I get 32 equals 64. Divide by 32 and get x equals 2. Now, I'm going to use the second equation. You can use the first one if you want, but I'm going to use the second one. Y equals 6x minus 4. I'm going to replace that x with what x equals. 6 times 2 minus 4. So I get 12 minus 4, and I get 8. So my answer is 2, 8. Okay, now on this one, notice how none of them are solved for a variable. None of them are solved for a variable, but if I notice here, there's an invisible 1 right there. So I'm going to solve for that y. Okay, the first thing I'm going to do is solve for that y. So I'm going to add 3x to both sides. When I add 3x, I'm going to get 3x minus 13. So now I'm going to take that and I'm going to plug it into this right here because it's what y equals. So 3x minus 13. I'm going to multiply. I get 15. Oh, no. I am not. Hold on, guys. I know what they've done. I'm going to make this a plus sign. And there's a reason because, yeah, don't worry about it. I'm going to take that. That'll get me 15x. This right here, see, they had this part first, and I had it second, and that's why it had the minus there. So that's actually going to be minus for our problem. So that's 1565. There we go. 19x minus 65. I'm going to add 65 to both sides. And I'm going to get 76. Oh, how many times does 19 go in? 4 times. So now I know what my x equals. And now I need to plug it into an original equation. So they picked this one for us to plug it into. I'm going to replace. You always plug it into the original equation, guys. Plug into original. Equation. Okay. So that would get me my y minus 12. Add 12 to both sides. And I get negative 1. So it's 4, negative 1. Here we go. The only one that has a 1 as a coefficient is right here. So we're going to solve for that first. I'm going to solve for that first. So x plus 4y equals 3. I'm going to subtract 4y, and I get x equals negative 4y plus 3. This is going to go in for the x, not for the y, but for the x. So I'm going to take 2. I'm going to replace negative 4y plus 3 minus 3y equals 17. So that'll get me negative 8y plus 6 minus 3y equals 17. Negative 11y plus 6 equals 17. Subtract 6 from both sides. Negative 11y equals 11. divide by negative 11, and y equals negative 1. Now I need to find out my x, so I'm going to take x plus 4y equals 3. I'm going to replace the y with negative 1. So x minus 4 equals 3. I add 4 to both sides, and I get x equals 7. So my point is 7 comma negative 1. Okay, on this one, solve the system of equations by substitution. So I'm going to replace my y with x plus 5. When I multiply that, that'll get me 2x. That will get me 10. So 2x minus 2x gives me 0, and I have 10 equals 10. Uh-oh, there's no more variable. It went all away. Anytime that this is a true statement, anytime that's a true statement, you will have infinite number of solutions, or infinitely many solutions. Okay, so this one. So I'm going to take this right here and I'm going to plug it in for x. 1/2, replace that and put in 2y plus 4 minus y equals 2. So half of 2 is 1, half of 4 is 2. This cancels with this. I have 2 equals 2. That is true. So that means it's infinite solutions. Okay, so let's do this next one. Oh, look at that. Neither one of them are solved. So you pick which one you want to do. I'm just going to pick the first one. I'm just going to, oh, actually, it's what they've picked. Yeah, they picked that one also. So I'm going to add y to both sides, and I get y minus 4. I'm going to take y minus 4, and I'm going to plug it into the second equation. So I'm going to replace the x right here. I'm going to replace that with y minus 4. Okay, y minus y, that goes away. And I have negative 4 equals 2/3. That doesn't work. They're not equal to each other. So this is no solution. So if it comes out to a false statement, then it's going to be no solution. Okay, look at this one. I'm going to solve for this y right here. So 7x plus y equals 9. Subtract 7x, subtract 7x. I get y equals negative 7x plus 9. Okay, I'm going to take the second equation. No, I am not going to do that. I am going to replace the y, this y right here, with negative 7x plus 9. Then I'm going to put the rest of this. Plus 7x equals negative 2. This negative 7x and this 7x cancel. 9 equals negative 2. That is a false statement. So your answer is no solution. So, May paid $15.75 for 6 greeting cards. Some of the cards cost $2.50. Some cost $3.25 each. Let X represent the number of cards that cost $2.50 each. Let Y represent the number of cards that cost $3.25 each. This can be represented by X plus Y equals 6. X plus Y equals 6. And then the other equation is 2.5x plus 3.25y equals 1575. And solve it. So I'm going to solve it for, I don't care which one's easier to multiply. I'm going to solve it for x. So subtract y, and I get x equals negative y plus 6. So I'm going to take this, and I'm going to plug it in for the x. So I have 2.5 times negative y plus 6 plus 325y equals 1575. Okay, so if I multiply here, I get negative 2.55y minus 12, that's 15. 15y, or no, not 15y, just 15, plus 3.25y equals 1575. Okay, combine like terms. So 3.25 minus 2.5, is that right? Yep, 2.5. 5 borrow 0.75, so 0.75y. Did I do that right? I think so. Minus 15 equals 15.75. Add 15. Get 0.75y equals 30.75. Oh, I see where I made my, that should be a plus, because that's a plus sign. That should be a plus. That makes more sense. That makes so much more sense. I was confused. Okay, so we should be subtracting 15 from both sides. 0.75, I divide by 0.75. I get y equals 1. Okay? And our original equation, one of our originals was x plus y equals 6. I'm going to replace the y with 1, subtract, and I get x equals 5. Well, what did x stand for? X stands for the number of cards at cost of $2.50. So there are 5 cards that cost $2.50. There is 1 card that costs $3.25.